Hello everyone, this is Changhyun Kim, also known as David Kim, currently in the second semester of my AI Master's course at FAU. Today, I'm excited to present the first deep learning exercise, Exercise0. In this exercise, our main goal is to utilize Numpy, a powerful library for numerical computing in Python, to create three distinct visual patterns. These patterns are a binary checkerboard pattern, second, a binary circle pattern, third, an RGB color spectrum. Now let's take a closer look at the implementation of checker class, which is responsible for generating the binary checkerboard pattern. So let's define a checker class that create and display a checkerboard pattern. First, we should import NumPy and Matplotlib library. Second, the class has three methods: init, draw, and show. The init method is the constructor which takes two parameters, resolution and tile size. Resolution defines the number of pixels in each dimension of whole pattern. Tile size defines the number of pixels that an individual tile has in each dimension. And the output variable is set to 0. The draw method creates the checkerboard pattern. It checks if the resolution is divisible by the double of the tile size. And then, as you can see in the left side, I create tile black and tile white representing black and white tile, and concatenate tile black and tile white to create concatenated 1, and concatenate tile white and tile black to create concatenated 2. And then concatenate concatenated 1 and concatenated 2 to create a 2x2 block of the checkerboard pattern. Uses np.tile to repeat the 2x2 block to create the full checkerboard pattern. And then assign the checkerboard pattern to the output member and returns a copy of it. The show method displays the checkerboard pattern using plt.imageShow. And I set the interpolation to nearest and the color map to gray for a proper visualization. And then I thought there could be something to improve from the original code, so I asked it to ChatGPT. So that was the ChatGPT's improvement about my code. First, remove the if-else block checking for resolution is divisible by 2 times tile size. Instead of that, an assertion is added. And then change the concatenation to include the axis parameter. So this is necessary to concatenate them correctly. Axis 1 means horizontally, axis 0 means vertically. So now it is better than before with these changes. So next pattern is circle. Before that, first, let's see np.meshGrid. This is a NumPy function that generates coordinate grids or meshes from multiple coordinate vectors. Given two 1D arrays representing the x and y coordinate, np.meshGrid returns two 2D arrays corresponding to the x and y coordinate of a grid. The primary use of np.meshGrid is to evaluate functions over a grid of points. It's especially useful when you want to compute a function or operation over a 2D space, such as generating a 2D pattern or evaluating a 2D function. In this example, x and y are 1D arrays representing the x and y coordinates. np.meshGrid returns two 2D arrays x grid and y grid, which represent the x and y coordinate of a 2D grid formed by the input coordinate vectors. The I, j element of x grid and y grid represent the x and y coordinate of the I, j point in the grid. Here is a brief outline of how to implement the circle class based on the given instructions. In the draw method of circle class, I create a 2D space with axis x and y. Further, I create a point space with np.meshGrid containing x, y points in this space, and thereafter using equation of circle I create a circle in the 2D point space. This is an improved version of circle class. I'll explain in detail about circle class at here. Create a circle class with a constructor that takes 3 arguments. First, an integer resolution, number of pixels in each dimension of image. An integer radius, radius of the circle. Third, a tuple position, xy coordinate of the circle center in the image. In the constructor, store these 3 arguments as public members and create an additional public member output to store the generated pattern. And the draw method to create a binary image of a circle as a NumPy array. At here, use np.mesh grid to create a grid of x and y coordinates. And the circle equation, x minus x center power 2 plus y minus y center power 2 equal radius power 2 to create a Boolean mask representing the circle, and apply the Boolean mask to create a binary image of the circle, and then store the circle pattern in the output member and return a copy of it, and then implement the show method to display the circle using plt.imageShow. So it's finished, and you can verify your implementation visually by creating an instance of the circle class in your main script and calling its method. And then verify your implementation by calling the unit test with test circle. And you should remember the key is to use NumPy operation to draw the circle rather than using a library function to draw it directly. This exercise aims to familiarize you with NumPy operation and working with pixel coordinates. Let's delve deeper into the use of np.mesh grid to understand it better. In this example, we have 2 arrays representing the x and y coordinates, both with a resolution of 400. So the x and y arrays have the shape 400, 400. Now we have 2 NumPy arrays, each with a shape of 400, 400, representing a 2D vector space. Each component in the x array and the corresponding components in the y array from a coordinate pair. These pairs represent each point in the 400 by 400 space. We can now calculate the distance from the center of the space for each coordinate pair, creating a new array called distance from center, with a shape of 400, 400. The result of this calculation is displayed here. Using this distance from center array, we can draw a circle if the distance from the center is less than the square of the radius. The point is inside the circle. Otherwise, the point is outside the circle. Next pattern is color spectrum. The draw method of spectrum creates 3-channel ND array spanned by red, green, and blue. This is obtained by a line space in the range of 0 to 1. In the constructor, you initialize the resolution and set the initial value of output to 0. In the draw method, I create a NumPy array OP of shape resolution by 3 and fill it with zeros. This will store the RGB color spectrum. Second, for the red channel, I set each row to a linearly spaced array between 0 and 1. This creates a gradient from left to right. For the green channel, I set each column to a linearly spaced array between 0 and 1. I use reshape to make it a column vector. This creates a gradient from top to bottom. For the blue channel, I set each row to a linearly spaced array between 1 and 0. This creates a gradient from right to left. And then I store the generated color spectrum in the output member variable and return a copy of it. In the show method, I display the color spectrum using plt.imageShow and plt.show.